Okay, so we have a 10 kilogram block. It is sliding horizontally with an initial speed of 4 meters per second. The coefficient of kinetic friction between the block and surface is zero point 0.3. What is the frictional force acting on the block, and how long will the block take to stop? Okay, so the first thing we want to find is the frictional force. And the first thing that we want to do is we want to write down our knowns and our unknowns and draw a free body diagram. So our knowns, we have mass. Let's write it to the side. 10 kilogram block. Its initial velocity is 4 meters per second. And it does come to a complete stop, so our final velocity is 0 meters per second. And the coefficient of kinetic friction is 0.3. And let's draw a free body diagram. So here's our block. It's 10 kilograms. We have a normal force acting up on the block. And then we have the weight force that's acting down. And there's no force moving it along other than its initial velocity. But the only thing that's really acting on it in terms of acceleration is the force of friction. What is the frictional force acting on the block? Okay, normal force. Okay, so let's write out our net forces in the x. So we have frictional force, which is UK times N. And we can't find our net forces in the x direction until we find this normal force. And to find normal force, we need to calculate the force of the weight. So let's do our forces in the y. So we have positive normal force, and then we have negative the force of the weight. And then there's no acceleration in the y, so it's 0. So we can write this equation actually as normal force is equal to the force of the weight. And we have our mass. Our mass is 10 kilograms. And then this is gravity, so 10 times 9.81, which is our mass, times gravity. Which gives us 10 times 9.81, 98.1. This is in newtons. And so we'll use this equation and plug it into here. So mu k is this 0.3 that we got in the question. So 0.3 times 98.1, which gives us, so our frictional force was 29.43 newtons. That answers the first question. And the second question is, how long will the block take to come to a complete stop? So in order to get our Newton's second law, force equals mass and acceleration, we have to find acceleration, and then we use that to plug into a kinematic equation. So we have our frictional force, and we need to find acceleration. So frictional force is 29.43, and then mass and acceleration. And we'll just divide this by mass, so 29.43 divided by 10, our mass. Which is 2.943. And this is actually negative because it's slowing the block down. And so the kinematic equation that we want to use to solve this, we'll use this formula here. So velocity final is equal to velocity initial plus acceleration times time. And we want to get time by itself, so we'll subtract the initial velocity and then we'll divide by acceleration to find time. So final velocity, because the block comes to a stop, is 0 minus our initial velocity, which was 4. Sorry about that, which is 4. And this is divided by the acceleration we just found, equals time. 0 minus 4 divided by negative 2.943. So time is 1.359 seconds for the block to come to a complete stop.